Hi, welcome to product review by WattHour. In this video we are going to do the review of this 50 volts 20 ampere WUZHI WZ5020L back converter, 20 ampere or 1 kilowatt. We are going to test it with different voltages up to 55 volts at the input and up to 20 ampere. I'm going to show you from time to time some thermal image to see which spot is getting hot the most. I'm going to show you the output. Also, I'm going to show you the output ripple voltage as well. Also, we're going to test input voltage, input current, and output voltage, output current reading on the display. Also, I'm going to show you how to charge lithium iron phosphate batteries, 1, 2, and 3 cells. Also, I'm going to show you how to calibrate the zero current, input voltage, output voltage, and output current. Let me show you the thermal image by visiting our website, watthour.ca. This is WUZHI WZ5020L 20 ampere 1000 watt back converter. This is a detailed video. On the larger screen you can click here on the status bar and you will see different chapters of the video where you can click and move to that chapter easily. On the mobile device, touch the title and you will see different chapters where you can touch and jump to that chapter easily. In this presentation, I'm going to explain the module. After that, briefly, I'm going to explain the components under the digital magnifier. Then I'm going to show you how to do the setting. After that, I'm going to demonstrate input and output voltage. And then I'm going to display the accuracy of voltage and current reading on the display. And then I'm going to demonstrate charging lithium iron phosphate batteries of 1, 2, and 3 cell with 3.2 volts each, and we are going to put them in parallel. I'm going to also test using oscilloscope the output ripple voltage. I'm going to show you the switching frequency of the output voltage. So here are the main features. We have constant voltage, which means the voltage will stay constant, and then we have constant current, which is needed in charging battery and many other applications, so you can protect your devices with constant current. And then it has display, LCD display, and it has soft start. So this is an important feature for many applications that will allow start softly via the software. The input voltage is 6 to 55 volts, and output voltage can be set between 10 millivolts to 50 volts, and output current can be set between 10 milliampere to 20 ampere. We're going to test all of this, and the total output power is 1000 watts. Input voltage accuracy is plus minus 1% plus 5. I'm going to test it, as I said, and output voltage accuracy is plus minus 0.3% plus 5. The capacity measurement is 999.9, that's 1000 ampere hour, and the time limit that you can control on this device is up to 100 hours. And output ripple voltage is typically 150 millivolts, which I'm going to test it and show you on the oscilloscope. The operating temperature, this might not be accurate because all the components and chip that have been used, they operate nominally at up to 125 degrees or maybe 85 degrees Celsius. So this is not accurate, I believe. These are the protections that this module comes with. Overvoltage protection is a feature that you can set separately the maximum voltage, and it will never allow you to set a voltage above that. Overcurrent protection also is the same, that you can set, for example, for some application you need only 3 ampere, so you can limit it, and you will never be able to do it by mistake above that setting. And then we have under voltage protection for some battery charge and some other application. Low voltage protection or under voltage protection is for the input voltage. If the voltage goes below certain value, the output will be turned off. And we have overcapacity protection. When you're charging a battery, you're, let's say, pouring 10 ampere hour, and you can set it when it reaches 10 ampere hour, it will shut off the output. And timeout protection, they put OHP over hour protection, so you can set certain amount of time and the device will turn off when it reaches to that time. We're going to test it with the input of 55 volts and output of all these standard voltages. Then I'm going to change the input voltage to 48 volts and output with these voltages, and then the input will be set to 24 volts and output of these voltages, and then input of 18 volts and output of these voltages, and then we are setting the input to 12 volts and output with these voltages, and finally I'm going to set it with 8 volts and output of 5 and 3.3 volts. So please don't forget to subscribe and click on the button on the lower right corner of the screen. This is a 50 volts 20 ampere step down or back converter from WUZHI. I've reviewed their products, they're very nice, and this is the package: WZ5020L, 50 volts 20 ampere and step down converter. It came in this package. We have the module which has also cooling fan, I think, with a screen with a little longer wire. I just put this tape so it looks cleaner. It can be used for charging battery or simply as a step down converter. Input can be up to 55 volts and output is from 0 to 50 volts. Because the maximum current is 20 ampere, you need to have proper wiring, thick wire. This is WG10 wire, silicon wire, which can handle the current. So make sure to avoid losses by adding very thick wire. Now let me explain the module. The module has input on this side. It says N, and it has been labeled here positive and negative, N minus and N plus. And this is the output. The negative is on this side, the positive is on that side. And we have here two 20 ampere fuses. So this is 40 ampere. A fan here this is the main inductor. It has been soldered and installed very properly. And here we have a Schottky diode here that is for the back converter, the main Schottky. The heatsink is for this component in here. This is the shunt resistor that is measuring the current. All the current passes through this, and we measure the voltage. That voltage that appears here across this shunt resistor is representing current, which we will see it here on the screen, the output current. This module has rotary encoder that you can set values, and also when you press it, it turns on and off and does some other feature which I'm going to explain. And we have one switch and I and V. This U is treated as V, voltage and current, and then we have CC LED, which is constant current, and also on, which will show you the device is on and off. And on this side we have just the TM612B, that's a display chip. And here this is the main microcontroller, and we have just display driver. And the cable here is labeled as keys, so these are just for the key, and these wires are for the display. Here we have an on-off switch where you can turn it on and off, and in here we have a constant current LED, and on the screen also you can see the constant current when the current reaches. Let's have a look at the components. First, we're going to look at this from this side. That is the XL Semi XL7005A. And here is a data sheet. This is 80 volt DC to DC back converter. The current is 400 milliampere. Let's have a look at this chip. So this has been cleared and we cannot read it. Let's have a look at this chip, the microcontroller. And as you can see, it's from WUZHI 76E003A. Here is a data sheet for NE76003. This is a 1T8051 base microcontroller from WUZHI. These three must be the same. This seems to be op-amps. LM358, the one that is close to the shunt. And this is also LM358. And here is the data sheet for LM358, low power dual operational amplifier. And the one that is close to the output is not LM358. This is NCE 6008. And here is the data sheet for NCE 6008. This is N-channel enhancement MOSFET. Let's have a look at these two chips here. And this is the NCE 82H140. And here is the data sheet for NCE 82H140. This is enhancement N-channel MOSFET. And the maximum current, the drain current is 140 ampere. The drain source voltage is 82 volts. And the RDS on, drain source when it is turned on, is 5.2 milliohm. That's very low. And gate source voltage is 10 volts. Pins are from the left, gate, drain, source. Let's have a look at this chip. So that is 12CW Q10FN. And here is a data sheet for 12CW Q10FN. This is high performance Schottky rectifier, 2 Schottky in one, each 6 ampere. So this is the one. And let's have a look at this Schottky diode here. And this is S10100. Here is a data sheet for S10100 Schottky rectifier. This is also dual Schottky rectifier. Maximum forward voltage is 100 volts and maximum current is 10 ampere. And let's have a look at this chip. And this is TM1621B. And here I found the Chinese version. This is LCD driver TM1621. So let's get ready and make sure to subscribe now. Now let me explain the features of this. The main on-off is this push button. When you press it, it is now off, and press it again. It has some delay, like half a second or 1 second. So when you push it, it turns on and off. The screen shows the input voltage or output voltage, and this is only output current, power, and capacity and time. So let me show you. To change it, when I press this quickly, it changes to hour. Now it shows the time since I turned it on. When it powers up, now it's 12 minutes. And then it shows the current, output current, and output power. Because this is now input voltage, press and hold this to change it to output voltage. Now this is output voltage. When you press this, it changes, short press will change only the bottom. Ampere hour, that's the capacity, and that is the time, and this is the current. And when you press it again, it shows watt. So whatever way you prefer, rest put it in ampere and watt. But if you want to see again the voltage, the input voltage, just press and hold. It shows you the input voltage and stays there. Now this push button here, I and U, when I press it, it shows to set the voltage. This U means V and I means current. Now it's blinking, but if I press it short again, it comes here, it allows you to set the current. Now it goes back. When it is blinking anywhere, you can rotate and change it, or press it to move to the next left digit and then change it. Press again, go to the next, even at 50 volts, you can set output voltage. And when I press it again, it comes here. So now I set it to exactly 50 volts. At this stage, you can just wait few seconds and it will exit. Or you can press this and hold it to exit. The same, you can do the current. We can set output current, whatever current you want, 17 ampere. And let's just wait for this. Hello. So it exited. If you press this for longer period, I'm pressing and holding it, it goes to this screen. This open on and open off. So it means that when you turn the device on, initially it will go on, the output will be on automatically right now. And let me disconnect the power. So I turned the input off. There is a capacitor. So now let's turn it on. As you can see, it went automatically to on. Now let me hold this and go here. To change this, press and hold this rotary encoder. Now it is off. Let me disconnect the power. And turning it on. As you can see, it did not turn on automatically, and that's what I would like to put it, this way. So now let's hold it and go to the next option. And at this stage, you can switch different option by this button. Press this, and now it says low voltage. This U treated as V, low voltage protection, which means when the input below this, then the device will turn off if it receives any voltage below this. So you can change it as usual. Go to the next digit and change it. And when I press this again, it goes to the next. Over voltage protection. That means output voltage, if you set it or make mistake, it will protect. What it means is sometimes you work with something that you do not allow, for example, above 48. So you can set this to 48 volts and it will be just 48 always. It will never allow to go above 48. And when I press this again, now this is over current protection. This doesn't allow you to go above certain current. This is 20.1, so you cannot set it above 20 ampere. So that's also good if sometimes you work with something that needs, for example, 10 ampere, set it to 10. And this is over capacity protection. If you want to charge a battery, you can set it again, press this. When you turn it on, that is where when you charge a battery, you can say, okay, I want to charge this battery with 20 ampere hour. And from here, you can just set it. Here, that's 20 ampere hour. And when you charge the battery, when it reaches 20 ampere hour, after that, it will stop. So that, but if you want to turn it off, press and hold, and it will be turned off. Now with the switch, let's go to the next one. This is over hour protection. This is like for time limit. When you set the time, you can set the time, so it will turn off after this much time that you set here. I will turn it off. I don't want to use it. And this is Z. Read this too as Z0. When I press this, this is a calibration of input voltage, and this is for the output. The same way you can calibrate the output, and then calibrate the current, and then again it comes back. At this stage, we just press this to exit, and output is off. Now I'm turning it on. When you set the current to whatever value it reaches, it reduces the voltage and keeps the current. So keep that in mind. And here is my on meter that I trust. As you can see, input is 55.5, and here we are reading 55.54, but that's also acceptable. Let's change the input voltage. (39.14, 39.1514), very accurate. Let's change it further. 22.24, 22.18, 9.44, 9.40, 30 millivolts difference. So input is 6 volts minimum, so 6.78, 6.75, very accurate. So this was the input. And now output voltage, I've connected my meter at the output, 0.2 volts, and we are reading 0.22. So we are reading 10 volts as 10 volts, very accurate. I'm changing it now, 16 volts, 15.96, 21 volts, still very accurate. Let's go 31, 38, so 5 millivolts difference, very accurate. 45, as you can see, it's very accurate. So output is 50 volts and we are reading 50 volts. Now let's check the accuracy of the reading for the output current. Let me turn it on. Output is 20 ampere and we are reading 20 ampere. And as you can see, we are reading 14.98, 14.97, 10 milliampere the difference. I'm going to reduce the current now. Output is 10 ampere, we are reading 9.993. Now output is 5 ampere and we are reading 5 ampere. Amazing. Output is 3 ampere and we are reading very exact value. Output is 1 ampere and we are reading 1 ampere. Very accurate. Output is now 300 milliampere and we are reading 320. Rounding because it doesn't show more digits. Now I'm going to demonstrate charging the battery. This is lithium iron phosphate. I have a separate video for this. The link is below the video. The videos will be posted soon. So I'm going to charge it. This is a 100 ampere hour, 3.2 volts. The input charge voltage is 3.65. Standard charge current is 20 and fast charge current is 40. I'm going to do this 20 ampere. And if you do it 20 ampere, if the battery is empty, it will take 5 hours to reach 100 ampere capacity of this. This is 100 ampere hour. First, let me show you the voltage of this battery. As you can see, the voltage is 3.2 volts, so 3.237. We're going to charge it at 3.65. The negative terminal is black and the positive terminal, so this is against all conventions. Turn this on to show you the output voltage. I've set it to 3.65. Let me show you the current. The current is also 20 ampere maximum. So I'm turning it off. Connected now. So this is now, it's reading now the voltage for the battery. Let me turn it on. And 20 ampere is being charged to this battery to 3.65. It needs more current, so the constant current is turned on, but we are not worried. As the current is poured up and this is filled up, then the voltage will be slowly increased and the current will be reduced. When this is filled up, it will be 0. Now let me connect my clamp meter to show you the current. And here, as you can see, 20 ampere poured into this battery. Now I've connected 2 cells in series, and then the 2 wires. So this is positive, negative is connected to the positive, and here let me show you the voltage. on my multimeter. As you can see, it shows 6.48 volts, and because each cell needs 3.65 times 2, we have to set the charger at 7.3 ampere, and I'm setting it at 20 ampere. The voltage is now set to 7.3 volts and 20 ampere. Output is off. Let me connect it now. And that's now 6.7, but the current is 20 ampere. Show you the current with this clamp meter. As you can see, the current is 20 ampere. So 20 ampere at 6.8. So this, as the current pours and this will fill up, it will reach to 7.3 volts and the current will be 0. That's when the battery is fully charged. Now I've connected 3 cells in series. These are 100 ampere hour lithium iron phosphate batteries. So let me show you the voltage first. This is the nominal voltage, 9.8 volts. And because we are charging it at 3.65 times 3, I'm going to set it at 10.95, the charger. I'm going to charge it with 20 ampere. 10.95, that's 9, and then 10 point, that's 10.95. The current is 20 ampere. Positive, these are connected in series. This is positive, negative to positive, and then negative to positive, and then we have one negative here at the end. Connect here. And as you can see, we are getting 18 ampere. The voltage will increase to 10.95 and the current will be 0. Let me connect my clamp meter so you can see it here. Here, 17.65 ampere, 17.7, and that's what we are getting. Let me check each battery. 3.3 volts, 3.3, and 3.3, and the total 9.99, and that is showing 10.18. Now the output is 50 volts, and as you can see, the current is now 20 ampere. Let's turn on the load. Now we have 20 ampere current is going out. Input is now 1032 watts, and instead of 1000 it shows A005. So it is above. This is now hex value. Hello. Perfect. Now I'm going to test it with 42 volts, 20 ampere, that's the maximum. And here is the power. 873 watts at the input, 15.8 ampere, and output is 840 watts. As you can see, constant current kicked in, which means it could not handle it, and the voltage is now being reduced. So let's reduce the output current. I've set output now to 18 ampere. Input is 14.2 ampere, 788 watts, and output is 757 watts. And here is the efficiency. Now we're going for 36 volts, 20 ampere. So as you can see, we are getting 721 watts. 752 is at the input. Input is 13.6 ampere. Constant current kicked in. At 36 volts, you cannot get 20 ampere. Let's reduce it. Now, output is 36 volts, 18 ampere. Input is 12.2 ampere with 55 volts, 676 watts. Output is 648.8 watts. If this can continue like this, here is the efficiency. Now I've set the output to 24 volts. Let's start with 20 ampere. Now we have 20 ampere at 24 volts. Input is 9 ampere, and as you can see, constant current kicked in, so it cannot handle it. Let's reduce it to 18. 18 ampere, 24 volts. As you can see, input is 8.2 ampere with 55 volts. Output power is 432.6 watts. Input is 455.3 watts. And here is the efficiency. By the way, the fan is running. Now I've set output to 18 volts with same 20 ampere. Current is 6.95, that's 7 ampere. 385 watts is the input, and as you can see, constant current kicked in, so we are unable to get 20 ampere. 18 volts, 18 ampere. Output power is 324 watts. Input is 6.24 ampere. 345.8 watts, and here is the efficiency. And here let me show you the thermal image. The hot spot is 58 degrees Celsius, 59, so not that hot. Now I set output to 12 volts at 20 ampere. 20 ampere at the moment. Input is 55 volts, 4.75 ampere. Output power is 240 volts divided by input power, 263.3. And if this can hold, here is the efficiency. Now I've set the output to 8.4 volts. That's a 2-cell lithium battery. Output current is now 20 ampere. As you can see, it is 168 watts. Input power 191.4 watts. And this, if this holds, here is the efficiency. The input current is 3.45 ampere. The fan is now off. I've changed it to 5 volts. The output with 20 ampere. 20 ampere, 5 volts. And as you can see, it's 100 watts, 5 times 20, and input power is 123 watts. If you want to know the current, 2.22 at 55 volts. Here is the efficiency. Now I set the output to 3.3 volts with 20 ampere. Input is 1.6, 66 watt is the output, divided by input 88.8. And here is the efficiency. Let's set it to 36 volts and let's go with 20 ampere. Input is 15.6 ampere and the output is 720 watts divided by 758 watts, and that is the efficiency multiplied by 100 if you want it in terms of percent. Current is now 10.5 ampere at 48 volts, and if this holds 480.5 watts divided by 508.6 watt times 100, and that is the efficiency. Now output is 18 volt and 360 watt with 20 ampere. Current is 7.95, that's 8 ampere at 48 volts. 360 divided by 385 times 100, and here is the efficiency. Now output is 12.6 volts, that's a 3-cell lithium battery. Input current is 5.67 ampere at 48 volts. Output is 252 watts divided by 274.8, 275 watts. Output is 8.4 volts, that's a 2-cell lithium battery charge voltage. 168 watts at 20 ampere. Input current is 3.92 ampere. 168 divided by 190. Now output is 5 volts 20 ampere. 100 watt is the output. Input is 121 watts. Input current is 2.5 ampere, and here is the efficiency. Now 3.3 volts 20 ampere, so 3 times 20, that's 60 watts. Input current is 1.8 ampere. Now I've changed the input voltage to 36 volts, that's another standard voltage. Output is 30 volts, this is the same as 29.4 volts for 7-cell battery. Let's go with 20 ampere. Input is 17.4 ampere. Output is 24 volts. I set it max 14 ampere at the input at 36 volts, and here is the efficiency. Now output is 18 volts. Current is 10.6 ampere at 36 volts, 360 watts divided by 384. Output is now 12. Output is 240 watts. Input is 7.2 ampere. Output is 8.4 volts, 2-cell lithium battery. Let's go with 20 ampere, 5.1 ampere at 36 volts. Output is 5 volts 20 ampere. Let me turn it on. 5 volts 20 ampere. Input current is 3.27 at 36 volts. Output is 3.3 volts 20 ampere. Let me turn it on. Input current is 2.3 ampere. Input is now changed to 24 volts. Output is now 18 volts 20 ampere. Input current, as you can see, is 16 ampere, and output is 360 watts divided by 386 watt at the input. Output is 12 volts 20 ampere. Let me turn it on. Input current 10.8. Output is set for 2 battery cell 8.4 at 8.4 volts at 20 ampere. Let's turn it on with 7.73. Output is now set to 5 volts 20 ampere. Input is 4.85 at 24 volts. Output is 3.3 volts with 20 ampere, 66 watts at the output, 82.6 watts at the input with 3.4 ampere, and here is the efficiency. Output is set to 15 volts with 20 ampere. And input current is 17.98, 18 ampere. Output is set to 8.4 volts for 2 lithium battery cells. Let me turn it on with 20 ampere. Let's see the power. 167.8 watts at the output, 187.3 watts at the input, 10.4 amperes at the input, and here is the efficiency. Output is set to 5 volts 20 ampere, that's 100 watts. Let me turn it on. 100 watts divided by 117.2 watts times 100%, that's the efficiency. Input current is 4.5 ampere at 18 volts. Output is set to 3.3 volts 20 ampere. Let me turn it on. At 20 ampere, that is 66 watts. The output is 82.2 watts, 4.5 ampere at 18 volts. Here is the efficiency. Now input is 8.4, that's a 2-cell lithium battery. Output is set to 5 volts. Let's go with 20 ampere. So as you can see, constant current. This cannot do it. Let me increase input voltage to see if that's the reason. Once it detects it, later on if you change the input, it will not take effect, so you have to turn it off and turn it on. Let me now reduce the voltage. As you can see, at 10 volts it will not work. Let's turn it off, turn on again. So even with 10 volts you cannot get 20 ampere. So 18 ampere doesn't work. (8.4 volts at the input, we can get 3.3 volts, 16.5 ampere. Output is 52.6 watts divided by 68.5 watts at the input with 8 ampere. Here is the efficiency. Now I change the input voltage to 12 volts. Output is set to 8.4 volts, 20 ampere. Let me turn it on. Input current is 15.8 ampere, and here is the efficiency. Now input is 12 volts, output is 5 volts, 20 ampere. (9.7 ampere at the input, and here is the efficiency. Now with 12 volts input. We are getting 3.3 volts at 20 ampere with 6.8 ampere, and here is the efficiency. When I connected with reverse polarity at the output, I connected this battery. The reason for that is they did not follow the convention. Black is always ground or negative, and then lighter color or red or other color is the positive. But this is the opposite. This was positive, that was negative, and now I corrected it. But before I made mistake, and as soon as I connected it, now the light is on, even though the voltage, when I turn it on, automatically it shows constant current. And here this LED also is on, so it has the reverse polarity have been connected in here and blown out something. I have to check it. And when I turn this on, automatically it goes to this mode. So this is telling me that something is wrong, and I realize I checked these two fuses, they have blown out. Now I can short circuit it with this hex key, and pay attention. When I connect it, when I short circuit it, that's the output voltage, and constant current disappears. So meaning that when you see this light on and constant current is on, even though you have connected nothing, then you know that the fuse has blown out. And here it says when you do the calibration, make sure that you calibrate it with a voltage above 12 volts and with a current above 1 ampere. And here, if you want to do this, the voltage and current calibration, just hold this, and from here we can go to the, this is zero current. Zero current means when there is no load, it shows some kind of current. For example, right now it shows 20 milliampere, and to zero it, just press and hold, and now this is treated as zero. To do the voltage calibration here, what you do is that's for the input calibration. We will put a multimeter and read your voltage. I'm holding it 14.11 volt. Now we have to set here as input 14.11, and then go to the next, go to the next. So this is 14.11, and then hold this. Now this is reading whatever you have. So input have been calibrated, and now press this. Now this is for the output. Let's read the voltage. So the voltage is 16.78, and let's set this 16.78, and then go to the next. .78, and once you're done, press and hold this, and the output voltage have been calibrated. The same way you can do amount of current. The output as 5 ampere. Now 5 ampere is out. The output as 5 ampere. Now 5 ampere is out. So let's calibrate this. So, and then hold it. Now output have been calibrated. To exit, just press and hold. And as you can see, it shows 16.95 and 5 ampere that have been calibrated. Let me connect this so we read almost zero on my meter. And let's measure this shunt resistor voltage, because that's a 20 ampere, as you can see. Let's read the voltage across the shunt. 66 millivolts. by Ohm's law. R is equal V over I. So V is 66 millivolts and I is 20. So as you can see, it's 3.3 milliohm. So that resistor is 3.3 milliohm. Now I have connected my oscilloscope. Now input is 55 volts, output is 50 volts, 20 ampere. And as you can see, the peak to peak delta is 102 millivolts, that's the ripple, and the frequency, switching frequency is 58.8 kilohertz. Now I've set the output voltage to 30 volts. Let's turn it on with 20 ampere, and output ripple is 142 millivolts. Now I set the output to 12 volts. Let's turn it on. Now, and the ripple is 128 millivolts. Switching frequency is still 58.8 kilohertz. Here you can see it very clearly that 100 millivolts is the peak to peak ripple, and the frequency is 58.5 kilohertz. Now the output is 3.3 volts, 15 ampere. Let's have a look at the output ripple. And here the ripple is 64.8 millivolts. Frequency is 55.2 kilohertz. It has been reduced a little. And here output is 24 volts. Let's go with 15 ampere. I'm turning it on. 15 ampere, 24 volts. Let's have a look. Frequency is 58.8 kilohertz, as you can see. And output ripple is 111 millivolts. Thank you for watching a video from Watt Hour. This was the review of this WUZHI WZ5020L back converter of 1 kilowatt. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos. In this video, we're going to do the review of this WUZHI WZ5005 5 ampere 50 volts or 250 watt back converter that can be controlled also via Wi-Fi of your phone Android device. I'm going to explain the module, how to use it with all the features and functions. I'm going to show you the minimum and maximum